Okay, it's 8:01, so we're going to start class, and no one's here, so I'm recording what I'm doing. We're going to start with number 47. Theta is negative 292 degrees, and they want me to find the reference angle, theta prime, and sketch it in standard position. Now, for most people, it's always easier to think in degrees. So if you think about it, if I go 292, I know 292, remember I'm going in the negative direction. 292 is bigger than 180, so I know I'm going to keep going around here. Let me subtract 180 from 292 to see how much bigger it is, because we can get confused about, what quadrant to put this in. 2 minus 0 is 2, 9 minus 8 is 1, and 2 minus 1 is 1. So it's 112 degrees more than 180. So if you think about it, I can get another 90 out of that. So it's like this. It actually goes 22 degrees into this quadrant, doesn't it? Okay, so this is a 22 degree angle here. It's a 22 degree angle right there. So if I want to know the reference angle, it's actually the complementary angle. My first student, even though I've started teaching already. So 90 degrees minus the 22 is 10 minus 2 is 8, and 8 minus 2 is 6. So my reference angle is actually 68 degrees. So my reference angle is 68 degrees. They want me to sketch it in standard position. I really kind of already did that. Okay? So let's go on. One that's in radians, 49. 49 theta is 11 pi over 5. All right, now let's think about this. 11 over 5 is, y'all just come on in and join class. I started without you since it was like 8:03. 11 over 5 is actually 2 1/5, okay? So 2 1/5 pi. So if I'm thinking about where that is, I'm going to go around a whole 2 pi, and then there's a 1/5 of pi that I go. So this angle right here would be pi divided by 5. So this angle in green, I'll write, is pi divided by 5. So I've sketched it in standard position, and I'm done with that one. That's the reference angle. I would use pi over 5 as the reference now. And I am going to write down the ones we've done so I can label the video accurately. Okay, 53 is 225 degrees. And the instructions say evaluate the sine, cosine, and tangent of the angle without using a calculator. So I'm going to come over here and say sine at 225 degrees, cosine at 225 degrees, and tangent of 225 degrees. Okay, so now basically what I need to do here is figure out where this angle is. 180 would be all the way to there. Now, how much bigger is 225 than 180? Let me just subtract it real quick. I'm going to get 5 minus 0 is 5, and 12 minus 8 is 4, because I had to go borrow. So it's 45 degrees more. That means this angle right here that I put a dot on is 45 degrees. So that's my reference angle. Now, one thing I might want to go do here, I know that not everything's going to be positive in that third quadrant. So let me go ahead and put that all students take calculus onto my graph. Okay. Since it's a 45 degree reference angle, do you remember off the top of your head what is the sine of 45 degrees? Y'all remember? Square root of 2 over 2. If I don't remember it, I can come down here, and I can make my little 45, 45, 90, across from 45, we'll call it A, across from 45, we'll call it A, and across from 90, we'll call it A squared root of 2, and sine would be opposite A over hypotenuse A squared root of 2, which is 1 over square root of 2, And if I rationalize that, I get square root of 2 over 2. It's better if we know it that fast, though, because see how much time we would have saved already, even if I can do that really fast. So it's square root of 2 over 2. Is it going to be a positive square root of 2 over 2 or a negative square root of 2 over 2? Negative, because it's in that third quadrant. Only the tangent is positive, so this is negative. The reason that is really, if you think about it, this side of my triangle is really negative a, and this side of my triangle is really negative a when I went down here to reduce it, and the hypotenuse was the positive a square root of 2. So when I did my opposite over hypotenuse, it would have been negative a over positive a square root of 2. That's why it comes out negative. But if we don't want to think that every time, we can just use the all students take calculus and just slap the sign on the angle after we get it, okay? That's what a lot of people like to do. All right, so now the cosine. Remember, instead of the cosine of 225 degrees, I'm thinking what's the cosine of 45 degrees, because that's the reference angle, and it is? Yeah, it's square root of 2 over 2, and then put the negative on it, right? Good. So it's negative square root of 2 over 2. See why it's nice to know those major angles. It saves us from all this work down here. Now the tangent, if you remember, is the sine over the cosine. And so if I were to put negative square root of 2 over 2 over negative square root of 2 over 2, yeah, well actually isn't it the same thing over itself, right? So it's a 1, isn't it? Because it's the same thing over itself. Square root of 2 over 2 over square root of 2 over 2. Both of them were negative, so it becomes a positive 1. And so that's what we're doing in that section. I want to do one that also has radians in it, just because that's the thing that most people have the hardest time with. So let's look at 61 next. Let me get to a different color other than red. All right, 61 is 11 pi over 4. Now, let's think about that. 2 pi here, a trip all the way around the unit circle, would be 8 over 4 pi, right? So I know I've gone around the unit circle one time. So if I want to subtract 2 pi from it, I can write 2 pi as 8 over 4 pi. That leaves me with 3 pi over 4. So I've already gone around the unit circle once. Now, really, I got to figure out where's 3 pi over 4, right? Okay, so 3 pi over 4. 4 pi over 4 would be all the way over here, wouldn't it? Because that'd be 1 pi. It'd be over here at 180. But I didn't go quite that much, did I? It's less than that. That means it's over here. So how much, if 180 is 4 pi over 4, because it's pi, but I'm just going to get a common denominator of 4, and I subtract that 3 pi over 4 out, what will be left? 1 pi over 4. Pi over 4, right? What is pi over 4? Y'all remember? If you don't, it's what? 45 degrees. You could get 180 divided by 4 in your calculator real quick if you don't remember it, but that's 45 degrees. And again, it's easier for us to think in degrees because it's what we learned first. It's kind of like your native language versus learned language, right? So this is a 45 degree angle right here. Let me put my all students take calculus on it so we don't have to worry about the signs. So they want to know the sine. And so the sine of 11 pi over 4 is just the same as the sine of 45 degrees. I'll just adjust the signs. What is the sine of 45 degrees? Square root of 2 over 2. See how much this one's popping up? Is it positive or is sine positive or negative in this quadrant over here where we figured out it was? It's over here, isn't it? It's positive, so we'll make that one positive. What's the cosine of 45 degrees, even though I'm going to write the original angle? Square root of 2 over 2, because 45 degrees, the sine and the cosine are the same, because it's an isosceles triangle, so your legs are the same. Is it positive or negative, though? Negative, because in that quadrant, only sine is positive, and then cosecant is reciprocal. So I'll put a negative here. How do I find the tangent? Sine over cosine, okay? Sine over cosine. So that means I'll make the sine was square root of 2 over 2. The cosine was negative square root of 2 over 2. Square root of 2 over 2 divided by square root of 2 over 2 is the same thing divided by itself, right? So what's your value going to be? Huh? It's going to be negative 1, isn't it? Because isn't it the same fraction on top as the bottom? So just remember, anything divided by itself, even if it looks as funky as that, is just 1. And this is a negative 1 because we had a positive sine and a negative cosine.